we populate this structure for the snapshot state with the received snapshot as well as its messages.
And that's it.
Mm-hmm.
So
I think we can show the running the.
Yeah.
Okay, well, I will stop sharing my screen.
Okay, I'll start by sharing the code and have the files ready. So I prompt the question on the forums actually, and asking for advice on, it was obvious that we needed to store the snapshots, and then we decided to go with the option that we're gonna have a map for the snapshot state, and we will have the snapshot ID, and with the messages also we're gonna have the snapshot ID plus the the node that where that snapshot ID is coming from. My function, the handle packet, is this one, which I actually prompt the question, which type of message is it? Is it a marker or a token? And then if it's a marker, as you put on the presentation, if there is not a snapshot yet, we need to snapshot. And then if it is a token, then we just add the tokens to this node, and then start. This is where all the messages are being stored on the form of. Oops, sorry about this debug line. The node and the current snapshot ID, and that's it. This is a start snapshot, which also was already explained, and the simulator. This function was actually really simple. That's why we merged it with this another one, the notify snapshot complete, which is finding all the available channels and then receiving the server ID for the snapshot, and then the collect snapshot, which is iterating for all the pending servers, and then when they receive the snapshot, it all gets into the global snapshot, or it all gets sum up into the global snapshot. So for the test, and I think I should make this. Can you see my terminal? I don't know if it's too small.
No,
Yeah.
we can see. Mm-hmm.
Okay. So I'm already on the route for the Chandy-Lamport algorithm. And then I think it's just go test. Oop, what happened? I don't know if I moved something. Just there. Yeah, something went wrong on the first.
Mm-hmm.
I don't know if I.
Yeah. I think that probably was some logging system because we got the same issue.
Yeah. So this is all. Well, I just left the debug on, but when the debug off, it just says pass, and that's it. That time, and that's it. I think we covered it in less than 15 minutes.
And you have extra time, you can like sing a song or something.
Yeah.
We are so efficient.
So basically, that's it.
Anyone has questions or doubt? Was it just one test? I'm checking.
I hope so.
There were included many tests, but when you run the Go test, runs everything.
Okay, cool. So no questions, doubt from anyone? No? Your solution was look like yours, different, exactly the same. Okay,
Looks,
thanks.
well, it looks with it almost the same faces. So they are very similar. Yep.
Okay. Okay, thank you, group one. There is any groups wants to go next, or should we go from last? Okay, so let's go from last now, group 8. Pedro.
Hello. Yeah, we are the team number 8. Let me share. Well, Charlie, I don't know if you want to share your screen. Do you have the code ready? Okay.
Okay. You can see my screen, right?
Yes.
Thank you. Okay, I'm going to start explaining the simulator or changes in the simulator. So we just added one field here that is the weight group, a map of weight groups. And we use this tool just for debugging, so please ignore them. So that weight group, when in this function, the start snapshot, this one is used to start the process in a specific server. So here we were adding the number of servers to the waiting group. So we wait until all of them finish with their snapshot. And when a server finishes their own snapshot, servers call this function, notify snapshot complete. And here we were saying that to the wait group that it's done, that process is done. And the last function of the simulator is this one, collect snapshot. This runs when all the servers have finished with their snapshot. So here we have a wait. So this won't run until all servers finishes with their snapshot. And basically what we do here is to collect the snapshots of each server and put them all in a single global snapshot that is this of type snapshot state with the ID of the snapshot, the tokens of each server, and the messages that remained in the channels. Yeah, and that's it for the simulator.
Yeah, just to summarize.
Can you go to the server, please?
Wait. Just to summarize to what Charlie did, we followed a different approach. We thought that it was the way to do it, right? So we created waiting groups, as Charlie mentioned, and this for each snapshot, we created a waiting group using a map of waiting groups using the snapshot ID, and for each snapshot, we are waiting for the servers to tell the simulator that the process of a snapshot has been completed, right? So when all the waiting group is called, when the done function is called the number of server times, then the simulator runs the collect snapshot, and then as Charlie showed, it just populates the snapshot message array. So yeah, it is just a different approach to team number 1. Yeah, sorry, Pedro, you can go ahead. Pedro.
Okay. Can you hear me?
Yes.
Can you hear me?
Yes.
Yeah.
Yes.
Okay. Can you still share, Charlie?
Sure.
Because I don't see nothing.
Pedro is gone.
Pedro,
We lost him. Okay.
Sorry, I was disconnected, so I will call to the.
Do you want me to explain this if you want?
do you wanna share this? Because I don't think I think I don't have the last version, the latest.
Okay.
Or I can pull it as you wish.
Okay. So this is the server part. Yeah, as in the group one explained, we had to process the packet sent by the simulator. Then here we have similar code, right? To check for the message type, if it is a token message, we are populating the server tokens with the tokens received from here. And we are using like a counter. This counter is increased for each snapshot in process called by the simulator, right? We are updating the inbound channels for each server, ignoring the source, which sent the first marker to the server. So then here in the marker, we are checking if it is already snapshotted. Then we are just calling the snapshot completed server function. Well, and this calls the notify server. I'm sorry, the notify. What is the name of this? Notify snapshot complete. So this called the DOM in the waiting group for a snapshot ID. And yeah, that's the way the simulator knows when all the snapshots, all the servers have called to the notify snapshot complete, and then the simulator is able to lock this function and collect all the snapshots for all the servers for a specific snapshot. What else? Well, that's pretty much it. We are for multiple snapshots happening at the same time. For example, in the 10 node, in the 10 node test case, we are updating all the channels for all the active snapshots in the server. So yeah, okay. So, and for the test cases, well, unfortunately, this approach worked for uninstalled test cases.
Can you hear me?
Yeah.
Yes, Pedro.
Okay. So while Luis run this, well, what I wanted to say is that one of the give me a sec. One of the main constraints that we have there is for example,
We cannot hear you, Pedro.
Pedro,
I think you're
Pedro.
very far away.
No, I think he thought he's because he called. I think. Actually, Pedro, we are hearing you through your microphone, not through your phone.
okay.
Yeah.
Well, what I was saying is when we were trying to develop this, at the first time, we thought that it was an easy project. We did a previous meeting where we were just explaining what we needed to do and how we were planning to do all the kind of stuff, and how we were to implement this our code there. And then the marker and the channels happens, and we noticed that it was not easy to actually collect all the tokens that arrive after the marker, and it was our main challenge there, to collecting all the tokens after the marker has arrived, and how we were going to save each token from the source server, and how we were to present those into the messages. So, and actually that was our main challenge. And most of the time, at the first we tried each one in their own computer, trying to do an approach. Then we tested a lot of approaches until, well, one of them started make sense to us, and we decided to go with that one. And this is the final result of what we developed. So Luis is going to run the test cases.
Yeah, fortunately, we couldn't make the last test case to work. This works for all the other test cases, but the Node 10 is the one that shows a difference in the channel. Here, for example, it says that the simulator has 1,000 tokens, but this snapshot only has, this is actually different. Oh, so yeah, this is, yeah, the moment that we started to test this, it was quite, late. Yeah, probably the approach that we followed didn't work. Well, didn't work, right? So yeah, it was quite late to start from the beginning and see what could we modify, because we noticed that what was happening is that the marker arrives, but then there is an additional token message that it is not being considered. So that's why we have the difference here. But yeah, and it was late to make the changes, right? So yeah, this is the test case that failed, and that's pretty much it.
Okay, so group one, Roberto, you didn't have the same problem? Roberto Saltania? No?
Sorry. Yeah, I mean, even when they used, I mean, we have like these problem like in certain runs, and then I thought, I mean, when I saw that they were using weight groups, I thought that could, solve the issue. But I see that it doesn't, because we were using channels to, blocking that part of the code, and yeah. But I think it runs like 8 or 9 times out of 10. So the odds were high.
Yeah, true. So for you, Pedro, I mean, sometimes if it's running or it never runs successfully, or sometimes it was failing, Luis, Pedro?
No, for us, it gives us always the same result. Yeah, it is always the same. It is always the same messages missing in the channel, and yeah.
Okay. Okay, thank you guys. Anyone has questions, comments? No? Okay.
No. Well, actually, we have a comment from the group 6, but we would like to present in order to go further on the details of our comments. Actually, we had the same problems, the synchronization problems, and we found a way in order to solve this.
Yeah, actually,
So-
it's we're going to continue with you guys. Let's
Okay.
Let's do it.
All right.
So
let
we're
me
going
share.
in reverse.
So he will talk and I will present.
Okay.
Okay, can you go to the files, please, Paul? To the ones that we should have modified. Server, simulator. Well, this is the first one. At the very beginning, we were required to update the struct for the server in order to connect the things that were missing. One important thing is the one that is highlighted, it was highlighted by Paul, is this snapshots data structure in which we are using an already data structure type provided here in the code, which is the sync map, which is providing a safe mechanism in order to use in a thread safe or to provide thread safety for our maps. Because, for example, if there is a shared resource, which in this case is the map, is a memory resource, whenever you want to process the information, or process or read it, you don't want to someone else modify it. So in that case, you need to provide a synchronization mechanism in order for the thread to avoid to be updated or modified by someone else, in order to avoid what is so-called a race condition, which this what we were suffering with our initial implementation, but we managed to use these sync map functions and structures. So if you go to the functions that we had to modify, the first one is the handle packet, which as was already mentioned by the other teams, this is to implement whenever the snapshot completes on the server, and this function should notify the simulator that we are done, let's say, with the snapshot complete. And this is done. Well, the first thing we need to do is to have a condition in order to detect which kind of message we have. In this case, we have two types, the tokens and the markers. As we already saw in previous classes and in the presentation from group 1, the marker is used to is used for the Chandy-Lamport algorithm in order to know that the snapshot has been already addressed. So in this case, we are using the start snapshot. Well, first of all, we check whether there is a snapshot on the received snapshot ID. If there is no snapshot, then we take it. That's the thing. I guess this should be almost the same in all the implementations. But always remember that we need to notify that the snapshot has been completed. So if we go to the tokens condition, in the tokens condition, we get the number of tokens, and we update the server with the number of tokens that are provided. And then the server remembers, this is very important from the Chandy-Lamport algorithm, the server knows whether it has been snapshotted using the maps, the snapshot messages, I'm sorry, that are provided there. So if we go to the start snapshot function, which is at the end of this file, can you go to the, yeah. This is very simple. We just create the tokens map, mapping all the keys to the expected token IDs. And then we create a server messages array in order to provide all the snapshot messages. And then we store the own snapshots in this map of the server. And in the end, what we need to do is to provide this information to all the nodes available, all the neighbors using this function. So yeah, if you go to the simulator, then in the simulator, we had to modify this notify snapshot complete, which is the callback for servers in order to notify that the snapshot process has completed on a particular node or server, let's say. And in this case, we are creating a channel in case there is no channel. And then Paul helped us to include this panic line, which was brand new for me, which this is like a condition we should not reach, never. Because if this reach, it means that the star snapshot was not triggered before notify snapshot completed. And in this case is where we were having a race condition.
Yes, we were having a lot of issues there.
Yeah.
Like...
It was passing, the test was passing 3 out of 5 times in our case. So yeah. And then in the collect snapshot, the thing important in this function is that this function blocks the process until the snapshot has completed in all the servers using this channel, as you can see. And we also are using this panic server in order to protect. And we are using the load function. If you remember the load function, can you go to the sync map file, please, Paul? The load function. In this file, the load function is using the lock mechanisms in order to provide thread safety. So this was already there. It was just a matter of using it. Well, first of all, it was a matter of seeing that we were implementing this not in a good fashion, but yeah, in the end, we managed to correct this. So if you go, yeah, if you have more things to share, Paul?
Yeah, only about this, like, yeah, we had an implementation that worked, as Hector mentioned, like 3 of 5 times. But after a while, sometimes it was misbehaving because each time that we executed this case, it was a bit different. So what we were looking, we were start adding first channels as locking mechanisms or synchronization mechanisms, but it was like a bit complex to do that. So at the end, by looking like all the code that we have, we realized that we had that sync map functionality already there because we were trying to use logs. So that's when, like, when we changed our implementation to use the sync map, it worked.
Yeah.
Yeah, and it was mainly because sometimes we were reading like some information and we were populating the same information at the same time because there are different threads or calls running at the same time.
Yeah, because of the concurrency that Go provides.
Mm-hmm. Yeah, and we had like a lot of like, well, this is the test case like running. Like we have still the log commands because we wanted to know exactly what was happening. To figure out our error, actually, we went through the simulation to see what the results it expects, and we try to adapt our code so it can pass, honestly. You know, that way we were looking what things were misbehaving.
Okay, I hear you got it run.
Yeah, and 100% times.
Yeah.
Yeah, no, very quickly. Okay, thank you guys. Thank you. Group 6, any comments from previous groups?
No, I think it's a great idea to add some line named panic line. I think that is just interesting.
Yeah, that was mainly like verification function, only to know that everything is executing correctly. That's why we put like we should not reach like these lines, otherwise there is something wrong. You know. And also,
yeah.
What I was going to say, yeah, something that it was challenging. It was that at the beginning, like the first test case is like the first test case, it's only by super easy because it's only making some returns in some functions. Honestly, the first test case is like an empty test case. The next test case is like the next two test cases, the two with 2 or 3 nodes were actually also really simple because of the presentation. But when getting more nodes, it gets a little tricky in how the process, like how the packets are managed. But the idea here is to think only like the communication between two, you know, like if you think that everything is like only communicating between two and only you get like this, the correct like tokens and messages, you should be able to implement it as if they were only two different systems. But that was a tricky part. Like I think that the most tricky part was like to think to create several arrays so you can understand what is actually a snapshot, because I also we were getting confused between the nodes and the snapshots IDs, because node 1 shouldn't have necessarily like snapshot 1. You know, snapshots are like some random IDs that are generated, and the nodes are only the name of the nodes, let's say. So those were like the things that were more complex. Well, the challenging parts. Yeah, we spent like a lot of time in the project.
Perfect. Thank you, Paul. Like last time, very precise. Thank you so much, Group 6. Group 3, apparently they want to go first. I mean, they were requesting me, so let's continue with Group 3. Then we continue with Group 5, so it's totally random.
Okay. Christian, can you present, please? Oh, thank you.
Okay, so we are the team 3. We are the first thing that we are going to do is we are going to run our test just to see that all the tests are passing. Can you run the test? Christian, please. Okay, so if you see all the tests are passing, so we are going to start explaining with the more basic test, that is the test to node simple, that it's doing this test with only 2 nodes. If you see here, we are going to go to the function run test that it's receiving 3 parameters that are 3 kinds of files. Christian, can you explain the kinds of files that we are having here?
Sure. So the first one is for .top, which means topology, and it's divided by 3 sections that we will review later. But basically, it will help us to draw all the information into our simulator. Also, we have these events that will come again later in the code, but it will provide all the action that will be happening in all the simulator in the between the nodes. And finally, we have the snap, which will help us to make the validation at the end after running all the codes to confirm whether if we have any errors or if we are matching the expected results.
Okay, so if you see here, we have the function, the run test, that it's receiving our 3 files that says Christian. And the first thing that we are doing here is that we are initializing our simulator, and then we are going to the read topology function. if you see here, we are receiving our file that in this case is the two nodes top and the pointer of the simulator. If you see here, the first thing that we are doing is that we are reading our file and we are saving all the lines in our variable that it's called lines. And if you see here the new epoch, where we had this one is created to add the cycles that occur in our simulator. So this function is just to know which structure it's going to have our simulator. So if you see here, we have our variable that we are assigned -1. That it's this is a kind of like saying that our variable is like false, something like that. And then we are going to start our for that it's going to read all our lines that we have in our variable. So in this case, our first line is like you saw it. We have the number 2, that is the number of servers that we are going to have. If you see here this condition, it says like if number served left is less than 0, then you are going to assign this number to our number of servers. So we have that continue here that it's like it's not like a break, but it's like adding a cycle in our for. So the next lines that we are going to read is the ones, can you go down, Christian, please? So if you see right now, our number served left, it's 2, like I told you, we have 2 servers here. And so in this condition, it says like if number servers left is more than 0, that in this case is 2, we are going to go to the next line that it's right now we are saving our N1 in this case in the server ID and the number 1 in our number of tokens. So we are going to go to the next cycle that if you see here, we are subtraction our number of servers left that in this case, we have 2 at the beginning and right now we are having 1. So we are going to the next line and add the server ID that in this case is N2 and the number of tokens is 2. So in the 2 last lines, we have the 2 nodes, that the one that it's sending our data to the other node, that if you see here, the source is the position number 0 that we have in our line, in this case like an array, and the destination that it's saved in the position number 1, that it's N2. So we are going to go to our function at forward link that it's going to be explained by Christian.
Yeah, so in this section, we are seeing that it is validating that the servers are working okay without any error. And here in the outbound link, we will have, as Ale mentioned, one source and the destination. So here is basically, we continue with all the topology for the simulator, and we are saving all the references. We are having outbound links and the inbound links. So that means we have one server with the pointer to a different server. And for the destination, we want to know from where it is coming, this link. So we try to put it as this to make it easier to understand. So we can keep in mind all these references for later once we start working with sending the tokens between all the nodes.
Okay. Just like a comment and difference for our teams. We are trying to explain in how we abort the code and how we discover how the code works and how to implement the parts that were empty. Okay. after this comment. Can we go, Christian, to inject events that is in this, this common go file, please? Okay, yeah, okay. Here we have, keep in mind that it is one of the important functions, because here we are indicating what things or what things are passing in what time. In this case, here the function is receiving like a file that Christian mentioned, that is the events file. The events file injects the events to the simulator, and it is expecting like a format. The first line is indicating the time steps. The first time, that is the N, is indicating the steps. The second line is indicating if you are sending or you are doing a snapshot, or if you are doing a seek. Can you go down, please? Okay, I don't remember. Yeah, can you go up a little up? Okay, first you need to read the file where it's doing. After that, you can have 3 different cases that I mentioned. That is the same, the snapshot, and the ticks. The send, as the name says, you need to have a source and a destination, and what is the message that you are sending. In this case, it is the token. It is checking if the file have any error, and also the ticks is indicating the like a time, that is like a steps that is happening. And I don't know if you, Brian, can want to explain the snapshot case.
Of course. Could you please access to collect a snapshot function, Christian, please? Okay, well, first, when we explain the snapshot, we first have to know what is a snapshot. Easy definition could be at least that it is a global state that consists of different local states of each process in a distributed system, along with transit message and communication channels. So in this function, we see that we have different states in the variable snap. Also, we iterate on the different servers. What we do is, okay, we have different states, and we need to send messages. Okay, when we iterate between the channels, well, we just add some variables and say, okay, that's what you're gonna do. And also in the first cycle K and B, we have to copy the tokens. So those are the messages that we are going to send, and at the end, well, we get all the message sent in a list or something. So Dorla explains the more. Dorle, continue, please.
Yeah, sorry, I was in it. Well, fifth, I think that one wall or one issue that we have here, where implement the function called snapshot. Here, basically, we was needing to iterate in all the servers and take the server ID, like Paul mentioned. That is something that we need to link with the paper, the Shandy Lamport. After that, we need to read what is the ID from the channel and get the server if it's a local server, or if it's a message from a local server, or what is the type of snapshot that we are processing. And so after that, can you go down, please? No. Okay, can you go to the servers? Yep. Okay, here another function that we need to manage is a function handle package. So basically this function is called for every simulation peak, and also it's handling every packet received well, if we have any package, at the server through the links connected to it. We keep in mind that we have two different packages, that is a marker message and the token message. The marker message is a marker that tells you the server tells you that the server needs to start the snapshot, and the token message is like the actual content of the server. Here the items or the tokens could be a snapshot. After the snapshot is complete, we need to notify to the simulator through the RPC. Can you go down? Okay, here in the function that start snapshot that we created is basically the process where Shandy is the process that is using the Shandy-Lamport algorithm. Basically, this function, this is a function where we capture the current state from the server, and we are storing the tokens that are in the server, and we are checking the marks if we are checking if the marks are completed. I mean, if all the sequence that involve the markers are completed. We have three different things here. That is the local snapshot, that is where you store your current status. The global snapshot, where you add the current snapshot from every server, and when the snapshot is complete. That basically is the key value pair to keep or to see if the tracking is complete. And I don't know if you can add something, Christian and Brian and Alejandro.
Okay, so that was all. It was very interesting that in the first project that we learned how to do a map or how to do a channel, and but I wasn't very sure how to use it. And here in this project, we learned how to apply the map. For example, in the collect snapshots, that we apply the map and in the channels too. And it was very interesting. And that's all. Thank you for everything.
Thank you.
We was a little nervous for the presentation, but if you feel that we forgot something, you can ask.
No, actually, it was very detailed. Thank you guys. Is there anyone has questions? Comments? Praise? Okay. It was very detailed. Thank you. Yeah, I mean, so far we had four presentation. How do you compare this second project with the first three projects? The difficulty level.
Can you repeat, please?
I mean, the project 2 with the project 1. How do you compare?
This was quite easier than the first one.
Yeah.
Well, at least for me, I've never worked before with Go, so the first one was quite difficult.
Yeah, the first one was the challenge.
Yeah, it's the same. Yeah. It's the same to me.
Because you had to get to know how it works. But now.
Yeah.
Okay. So.
Because you have two variables. For example, you need to learn about the new algorithm, and you need to learn about how implement it, because it's a language that you don't use. Yeah.
Okay. Perfect. Good to know. So let's have like 10 minutes break. So we come back 7:45, and we continue.
Okay.
Okay. Meanwhile, Pedro, you're here. Pedro Cortes and
yes,
Jose Roberto. Pedro, it's the case is Jose Roberto is has only one group member, okay, to do the presentation. And you also, I noticed you also have one, basically, you know, your group, Pedro, the other students is already basically dropped the course. And we have another groups, which is group 10, presentation group 10, which has also one student only. So if you're willing, you can work together as one team.
Sorry, I didn't get that.
For the presentation, if you check your group, you see you are the only one in the group because another students already dropped the course.
But I am in group 8.
That's for project. You have another grouping for presentation.
I thought we were together for everything, the three of us.
No, the presentation groups are groups of 2. I think maybe you forgot. Let me show you my screen.
Yeah, sure.
Oh. This is the situation. We have a project group and we have presentation group. In the presentation group, we have, you're here, Pedro, and we have Jose Roberto here. This is students already inactive. Okay, we dropped the course. This is students already dropped the course. So if you're willing, we can like merge these two here. So you'll be group 10 for the paper presentation. This is the paper presentation.
Okay. I mean, like you say, like we were the last 3 in the course. You say that we were together in the same group, but
Yeah,
it's okay. I mean, no problem.
In the project, you are in same. But
yeah, but I thought you said the same for the presentation because you said that we didn't have a subject. You say that later you will find something for us.
Did I? Okay. Yeah, like now I remember.
Because right now I don't know what is I don't know right now. I don't know what is the presentation for my team.
It will be paper number 10. If you check it out. Let me see. Discussion. It will be this one, this paper.
Okay.
Basically in 3 weeks.
Okay.
But I mean, if you're okay with that, I remember I said something like that in the early, but then I noticed that one student is basically because the student they dropped the course, so again things change. The dynamic.
Okay, no problem. I can work with Roberto in that one.
Okay.
I can work with Roberto with that one.
Okay. It's good paper. It isn't difficult really. Okay. So when he come back, we'll talk.
So Madi, one question regarding that. Then Charlie and me will have to present the last paper because there will be one paper missing, right?
Actually, I was thinking for your group, we can have another paper because now if you see, basically we will, if I merge these two, let me merge these two. Remove. If I merge these two, then just remove. Then I don't have this group anymore. So we have basically, this would be the situation. I can rename this. So we have, how many papers we have? 12 paper or 11?
I think they are 12, I think.
If it's 12, then it's a fixed number. But yeah, Akamai is the last one. Mm-hmm. Yeah, so you will be basically presenting the last one.
Okay, thank you.
But anyway, I will merge two groups in one day because we wouldn't be having enough weeks to go one by one. So 1 week there should be 2 presentations, and maybe we set it for the last week. I mean, last week before the last project presentation. But anyway, I'll discuss. Maybe I'll check it out the schedule next week. I'll say okay. Maybe we go these 2 in the same day, like this one and this one.
So I consider that with 14 is Spanner and Snow. So we are going to have a double presentation, or also Spanner is part of Snow.
No, they are 2 different papers. So that's what I was looking at. Let me see.
Actually, I have the same question because in 3 weeks, suppose I'm going to present Spanner, but Spanner it's in 3 weeks on November something. Yeah. And I saw that 1 week before, actually, you are going to present Spanner.
Yeah, that's right. Or maybe we make this Spanner and Snow one day, so you just present Pedro Cortes with, Pedro team with Paul team.
I didn't understand.
Let me see. Let me see the schedule. Course calendar. So now we are
21.
21. So we have 1, 2, 3, 4 in general. If it's the presentation, this is exam. So if I bring this here.
Yeah, because supposedly I present the 11, that it's G11, R11.
This one, yeah.
Yes, that's Spanner.
So yeah, so the best idea is, I think it would be G10 and G11, they present in the same day.
Mm-hmm.
Like Pedro and Paul. So we have basically, anyway, this comes here. So maybe we do the same thing with the patches and wraps that we did. So it was both on the same day. So maybe Spanner and Snow, it comes here anyway, and we can have both presentation here.
Okay.
Okay.
Okay, so nothing changed.
Yeah, basically, yeah. I just
yeah, fine.
The last one will be alone, maybe for Luis Montes. Most probably, yeah. I mean, we merge these 2, or we just eliminate one of them, or we just talk about the wrapping up here. We don't even talk about this. Okay. let's continue. Okay, if you're here, please come turn on your camera. Let's see each other. Let's continue with group 5. So to have it more random. So we have group 1, 8, 6, 3. Let's continue with group 5.
Yep. Okay. Okay, well, let's start. The way that I want to do this is to first explain what was the process to accomplish this project and the assumptions that we did that gave us a lot of headaches, right? So first of all, well, the first step was to understand the algorithm, then understand the code. And once that we had that ready, we started with the first implementation that worked for the first test, but had a lot of issues. Basically, the main assumptions that we did that were wrong was in our first iteration, we thought that, okay, based on this really simple example, we assume that to be sure that the snapshot is ready, we just need to have the tokens of the state, and we need to read the channels until we get a token. But the thing here was that we were looking for all the servers on the system instead of checking if we really had a connection with them. So that was the first mistake. The second one was once that we get a token, we should stop taking care of that channel as part of the snapshot. We keep it up, picking information until we close the snapshot. So we ended up with a lot of duplicate inbound tokens, right? And the last one was the assumption that we only need to take one snapshot. So yeah, those were like the main issues that we had. The way that we solved them was understanding how the testing was done and doing some reverse engineering, trying to figure out, okay, they are expecting us to just validate the amount of inbound channels, right? We need to validate, we noticed that, okay, another snapshot happened. Our implementation is bad, and that kind of stuff. Once that we had that ready, we came up with this solution. Where is my, okay. Yeah, actually I am already there. Okay, so as you know, the code is divided in server and simulator. Simulator is more like the orchestrator of the operation. It's the one that it's triggering the operation with, in a second, the snapshot function, and then it is in charge of triggering it in a server, and well, not server, in a, on a server, and then trigger the operation. So first here, the logic, it's not really complex. We just trigger, call the server start snapshot implementation. We had this snapshot complete, notify snapshot complete. That means that a server ended the job, and then it notifies the simulator that snapshot for that specific node, it is ready. So we are just having the counter for that, and we increase the counter. And here is interesting logic. First of all, well, when we trigger a snapshot, we start the collect snapshot operation. So we wait that for that specific snapshot, we're saving actually that information on a slice. We have an array with all the snapshots related to that specific ID. Once that we have all the information from the server, well, while we don't have all the information from the servers, we are just sleeping. Actually, we did an implementation that is a little bit different from the others. We are not using channels, waiting for the report for the server to report the issue. So we didn't have all that how to call it run concurrency issues. Yeah, sorry. Thank you. Then once that you have all the information, we just pick it up from all the servers. We make we solve the puzzle, and we return the value of the, well, return the information related to that, the full context of the system. And after that, we restart our snapshot ID saying that it's not completed in case that we want to reduce the snapshot ID. This logic, it's very simple. For each server, we just get the tokens stored there, and we get all the values stored as part of the inbound list, all the information that we got as part of the channel, right? So yeah, that is like the main idea. Jose, do you want to add something about this, or should we jump into the server?
I think we should jump into the server. Any doubt?
Yeah, Jose is going to talk about this. So let me know, where do you want me to place the...
Okay, yeah, that's okay. First, we add just into our server structure a list of snapshots, so we will know which snapshots are triggered, and we added a new structure, which is there, snapshot, which has, if it has started, how many tokens and how many markers received, and and the inbound list.
Yeah, and we'll start as part of the server. Okay, do you want me to go down?
Yeah, please. Into our implementations of handle packet. Yeah. Basically, as other team has said, we just need to check two different messages: the token message and the marker message. The token message, we just need to put it on our snapshot if the snapshot has already started, and if it has already completed, then just put it on the other server, but not on our snapshot. That was one thing we missed out on some of our first implementations. And from the marker server marker message, we just need to see if we have already gotten one marker message or not. If we haven't, then we start the snapshot. If we already have, then we finish this. We check against all our inbound links, and if we have received all from the other servers, then we have end our snapshot from that server. Basically, what the Chandy-Lamport algorithm says you need to do. And when this has completed, then we say that we no longer have started the snapshot, so we have completed that snapshot and notify snapshot complete.
Well, this one is just the initializer of the snapshot, and when we start, we need to send a marker to all the neighbors. So yeah, I think that the main challenge for us in this code was to understand it in a bigger scale, right? The two node example, it's too easy, so we lost some important points in this.
Some corner cases that were not covered by those tests. So with further tests, we caught those issues.
And also understand the code, right? For example, how all these interfaces are used. And yeah, I mean, once that you remove that from the equation, it was not as complex as the previous homework, well, assignment. Yeah, what else can I add? I mean, I can show, yeah, there is another point. This is something a little bit funny about the implementation. We noticed it before today, but well, right now, the thing that, the way that we support at most 20 snapshots as part of this test. We could improve this, probably changing this structure by a map. If you change it by a map, you can keep growing the amount of snapshots, and probably you will need in your simulator logic a way to trim the map at some moment, right? To clean all the completed snapshots at some moment. It depends on the implementation. Probably if you want to store them, you could pick up all those snapshots and just save them on logs or any file to keep track on this. But right now, that is one limitation of our current implementation.
One hack.
Sorry, was it?
One hack of our implementation.
One hack to let the testing work. Yeah, we thought a little bit about implementing Cube, for example, but the thing with that is that the way that we are identifying which is the snapshot that we want to check, it's based on an index. So if you remove values from the list, then it will be a little bit trickier to get the right one. So yeah, I mean, there are ways to improve this code. Those are the limitations, some solutions that we thought of, but when you change your data structures, you need to rewrite all your code and you end up having some new issues. So we wanted to play safe for now. And well, the results, all the tests go fine. Actually, I think here, if you want to reduce the time here, you can make a change in this simulator code that it is sleeping for 10 milliseconds, and just check it. Checking
a busy wait,
yeah. A threat to be alive all the time, right? So it's a better practice to do this. I mean, yeah, a few milliseconds where it won't really impact. So yeah, I think that is the general idea of our implementation. I don't know if there is anything that Jose wants to add.
No. Do you have any doubts about this implementation instead of using the channels?
No. That was interesting.
No.
Approach. And anyone has questions? Doubt? Comments?
Nope.
Jordan wants to finish it as fast as possible. Okay, thank you guys. Thank you, group 5. Let's continue with group 4. If you're going.
Just a moment.
Okay.
All right, so we are group 4. We are going to try to go through the functions of the project in more or less the same order than the Chandilampo algorithm. So for that, we're going to start with the start snapshot function. Let's not get confused here. There are two start snapshot functions, one in the simulator and another one in the server. The one in the simulator is in charge of starting the snapshot per se. It's gonna select one server using the server ID, and it's just gonna start the snapshot there. In the start snapshot function, we are also creating a channel. I guess most of the teams we did it that way, and call the start snapshot function in the server using an RPC. Can we move to the next one? It's in server. All right, so by this time, one of the servers has been told to initiate the snapshot. In this function, we are gonna capture the local snapshot of that specific server, and we are gonna store that snapshot in another struct that we call global snapshot, that we are gonna use to just add up the snapshot from all the servers. Kudos here to the people who asked in the forum about the struct to use to store the snapshot, because before that we are gonna try to create our own, and that was gonna cause an overhead in the code. Anyway, this function also tells every server connected to this specific server to start their own snapshot process. And I think that's it. Moving on to the next function. David, do you want to take this one?
Yes, for the handle package. This function is implicitly called after every simulation clock. The function tick. This one is calling handle package in every cycle. And also we have the same logic. We have a marker message that tells the server to start a snapshot based on the Chandil Lampard algorithm. And the token message are the actual content on the server that are the items to be snapshotted. And for example, for the marker message, if we check if the snapshot is already made it. If not, we do a start snapshot, and we notify with an RPC to the snapshot completion. So if there is no marker message, it's told that is already snapshotted. So the token message, if the server receives a token, add up number of tokens currently in the server and update the snapshot. So we are updating the snapshot. So we are getting advantage of the structs that the frameworks provide us, like range and store, for example. That we agree with the team, I think the team 3 say that using sync map makes the things a lot more easier. You can concentrate in the algorithm instead of the synchronization. So it makes it's possible to concentrate more in the algorithm that in the synchronization. So this is all for handle package. And I think it's here.
And then it's so then we get to the function notify snapshot, and this is basically just an RPC that is called every time the server completes a snapshot. And once the RPC is made and the call is made, we go to the function collect snapshot. So the function collect snapshot stores all the completed snapshots into one single structure of snapshot state type, and it iterates in every server, collecting every snapshot in the servers. And it uses a channel called snapchan to retrieve the snapshot from every server. And then it goes through every token into so they can be stored in a final snapshot. So yeah, this is basically the function that returns the final snapshot of the whole process. I'm sorry, I'm really slow. I'm really tired today.
No worries.
Maybe you want to run the test, David?
Yep, sure. It's go test, right? Yep. Yes, this time. So the only question that I have is when I see the time, it's that in the example of the run test, it's also mentioned only this quantity. It's way more or less than every team. So I wonder, it's a matter of the machine that you are running the code, or it's or their algorithm it's or the implementation, it's getting more advantages of the more channels. So I don't know. It's a question that I have, because no other team is also reaching so small amount of time. Yeah.
Does that value is mentioned in the code, in the description?
No, it just very in this part when you run the test in the GitHub page. Yeah, it's the same test, but it's way more less than we have, and I think the other teams also. So I get curious about if there is an implementation subject, or this is a more than how powerful is your machine, or I don't know. I was questioning about it.
The time execution?
Yeah.
Yeah, that like actually varies. Like I coded in one computer and I shared my code to my other computer and then I pushed the code and it executes differently. Like I have like a 2020 computer and I have a 2012 computer, and in one it executes like super slow. The one actually is the one that I am using to present, that I used to present. And also it depends on how many processes you are running in the background on your computer, because also when I was like pulling some information or fetching some information from online, when I was trying to execute Go, it was like super slow. And when I stopped like those background jobs, I could work like normally. So actually it depends on that, and also yes, the implementation. Like for example, when we were collecting snapshots on demand, and some people wait for all the snapshots to be completed before collecting the information.
Yes.
And also depends on whether you are using a virtual machine to run it in the environment. I mean, if you have a Windows system but you are using the Bash as a virtual machine, or you are using a purely Mac computer, so that also.
But the question is that is the expected time.
It is not. It's just an,
yeah, it is not.
Just an example of the output. On
Okay.
The,
yeah.
But it isn't explicitly saying that.
Yeah. No. That's.
Yeah. And also one more is that, like for example, some of the other teams like mine, we have some log statements, and actually that default stream output, it's super slow, like literally
Yes.
slow. So that also adds a lot of overhead.
Yes, if we run with the true. It's a way more.
Yeah.
Yep.
Yeah.
Yeah, that's expected.
Yes, very logical. So that's all for us.
Okay, thank you guys. Group
Thank you.
4. Let's go with the last group 2.
Hello. Can you see my screen?
Yes.
Okay, we are going to start like the process goes on, and the simulator. We only added, we use the approach of using channels to lock the execution and the collection of snapshots. That's the only field that we added to the structure. And everything starts in the start snapshot process. And the only step to do there was to obtain the server that is indicated by the simulator, extract it, and call it start snapshot method. So here the server is where actually does the work. Saul.
Yep. Yeah, that is not start snapshot function calls another snapshot function, because we need to use that function in both flows of the Chandilarpur algorithm. That's why we extract that part. And in this case, for perform snapshot, it's quite easy. We just need to take the tokens that this server have, and just create an empty array message. And we in on server snapshot property, we set that state with that this current server has n tokens and messages. There are no messages because this current server is executing the snapshots. Once we have created the snapshots, we need to notify our neighbors. We need to send our current marker to the neighbors in order to they perform their snapshots. And after that, we also need to notify our simulator. In this.
So yeah, can you access that function on the notify function? Yeah. So as Saul said, it's where is it? Oh yeah, it's a simple function. It just takes the simulator struct and checks if there's already an open channel to communicate. If the snapshots, well, just to communicate just the current state of the snapshots. So if it isn't open, it just opens one, it makes one, stores it, and then it just then it sends the server ID in the collection channel. So this will allow the function collect snapshot to be accessed later on through the common underscore test. A go routine will be triggered, and later on the collect snapshot function will be available. Well, I don't know if you want to.
On the server, the messages types are two: marker message, token message. Token message is the one that is executed when a token is sent from a server to another. We extract the tokens from the message, modify the server state, and this is I think the most tricky part of the project. That was to check if the server already had a snapshot. And we use an array of flags to identify which channels are with messages in transit. So we check here using the snapshot ID and the number of the server that is sending the token. If it is open, we check here if the array of flags isn't false for that combination. Then we are storing those messages too, because are the token messages that are in flight during the snapshot. So only in that case we store the messages. But this flag is modified when a server receives, in example, a marker message. When a server receives a marker message, the server takes the snapshot if it doesn't have it already, and it closes it modifies the flag for that combination. So any incoming message, token message that arrives, it will not be stored in the snapshot. It will be processed, but it will not be stored in that snapshot. Well, that is for the messages. And I think the last part is the collect snapshot.
Yes, for that part, once these servers are notifying that the snapshot was taken, we can access that function. First, we collect how many servers have already finished. Then we iterate over those servers, and we just deplete the pending servers values. So when that while loop is over, we can later on iterate over the completed server ID, and that gets stored in the snap object. Later on, the snap is stored in another variable in the common underscore test part. And that's it for that function.
Yeah, I think that's it. We can run the test. So no passing. We also have that similar time. So okay, that's it. I don't know if there is any question.
Thank you, Marco. And thank you, guys. Any questions, comments from others? No? And by the way, do you remember the whole idea of the snapshot? What was the whole idea of the snapshot?
To get a state of the process.
Global state, right?
Yeah, true. I wanted to make sure you know what you are doing. It's not. Yeah, that was to get the basically global state of the system. Thank you, guys. it was much faster than the first one. First time we ran out of the time. But this time we get it done on time. So, okay, from next week, we're going to continue basically our talk. We're going to have a next presentation by the students. It will be about frangipani. Just remember, okay? I mean, from next week, it'll be more normal process again. I don't know if anyone has questions, comment about the activities that we did, quiz, assignment, project.
Yes, I have a question. When is the last day to review the assignment to do like write comments about the assignments from other students?
Didn't we discuss about that before? Okay, it should be, let's say, latest by tomorrow, okay? Because by tomorrow I should, I think, report the second partials. I think the deadline will be, yeah, Friday. I should. So if you haven't done that to review, please review because I see I already received all the assignments. Okay. So
Maddie, is it only 2 reviews per assignment?
Yes.
Okay, but there's no. I forgot the name of it. Rubric.
The table of the square. No, I haven't assigned rubric. So it's mainly reading and putting your comments. So it's not about grading really. It's about reading and putting your comments. If you like it, I don't know. If you have any comments on that, I can see majority have already done that. So there are just a few 5-6 students that haven't done the peer review. Yeah, just do the peer review, just review it, and yeah, that's it. No grading, no rubric for this time.
I have a question.
Go ahead.
You mentioned that you have to give the grades already for the second partial. Like at least we have then our next exam for our another topic. Well, another, what's the name, class until next week. So that's like something like unexpected for me, at least.
Which
that
one?
you like tomorrow we have another class that it's a fundamentals of programming.
Okay.
class, but we have the exam next week. So it's like only unexpected for me because it says that that you have to deliver the grades like this week, and the other teacher has the class the exam next week.
So I don't want to comment on that, but I can double check the calendar to make sure I'm not confusing the dates, because what I remember is like I set all the times based on the deadlines of the basically partials. That's why, like you see, by this week we have already finished like a quiz, assignment, project. So that's what I remember, but I can double check the calendar. Let me check it to make sure when is the partial 2. I find the calendar. If you give me minutes, I can check and make sure I'm not confused.
Yeah, I was only saying because probably there is a little more time for the reviews, right? It was mainly because of that.
December, October. Here, like I can't find the calendar. That's strange. You mean so? What you're saying is like you need more time to review?
No, but you mentioned that some people missed that, right? So
Yeah, but it's just 2 page.
okay.
Two assignments, each one is 1 page. So it's even you can do it. I don't want to like keep you here and say, okay, let's say like let's say spend the next 30 minutes just to read that 2 page, but you can do it on your own.
Okay.
It's just 2 page because each summary isn't more than 1 page. That was the basically requirement. So reading 2 page, I guess, takes 15 minutes max. I mean, 5 minutes loading, 10 minutes reading.
Okay. Yeah. No worries. No worries.
But yeah, but unfortunately, I can't just. Oh no, I find it. Okay, I was looking for this. Examine partial. Partial.